Good afternoon, all of my friends. Elliot, how are you? Good to see ya. I'm doing so good. Thank you so much. It's good to be back. Back in the saddle, back in the seat. See if I can figure out how to share my screen again. Make select. Oh, I remember this. There we go. I think so you can see my screen, yeah? Nice. I think the obvious first thing to call out is our latest and greatest best app online, the kalepail Elliot project. This beautiful piece of work where you can trade your hard-earned. So if anybody's new to what we're talking about farming our kale, right? But now you can actually begin to do things, and I think, Elliot, we are owed a brief explanation from the man himself, plus some alpha on what the plans are for the kitchen, because this is unacceptable. Pretty sure it's like having coming soon text on a website is very early 2000s. Yeah, I'm not sure we're allowed to do that anymore. That's kind of interesting. I'm very excited about that one. I think it's like kind of what I had thought about doing, where you had NFT recipe cards, or maybe there's like these short-term events where, I don't know, you got Valentine's Day coming up and you got to cook some chocolate, but it requires burning your vegetables. Or I do think that there's been an outcry for meat, so apparently we need to open up a meat shop, a butchery. I don't know, it sounds sus, but I love it. It's one of my favorite things now that you can take something basic like I don't know, a weird mining, farming game, and then begin to build on top of it other things because it's built on blockchain and you can call those cross contracts, and pretty cool. Cool. Be sure and check that out. But we're not here to talk only, or really anymore at all, about that. I want to talk about indexing. We're not going to get as deep maybe as I would like. It's a pretty complex topic. But I am going to talk a bit about Mercury, Zephyr, RetroShades. So there's the service called Mercury. If you just go mercurydata.app, you can find all of the bits and bobs that I'll be referencing today. It's definitely by far, that isn't even linked to a HTTPS is what we need for that. And I just closed the chat. HTTPS. There are several different, I don't even know, maybe Elliot, you can link to the page that has other indexers on it. But basically what an indexer is fundamentally is a way to get on-chain data into more digestible or processed formats for you to use in your applications, whether that's backend or front end or analytic applications. Blockchain data is notoriously unusable because it's compact or it's encoded. Like we have all our data encoded as XDR, and so there's no way to like query it for give me all of my asset. Give me all of the asset holders for this particular asset. Give me all the asset holders that hold more than 0. There's so many questions you might need to ask of the data, blockchain data, and there's pretty simply, there's no way, because it's like this infinite number of queries that you need to make, there's no single way to get that data into a meaningful format. And that's where indexers come in. Some indexers are pretty dumb, where all they really do is like give you a GraphQL endpoint where you can kind of just query all the data, and it takes it from XDR format into some sort of like Postgres tables and rows. So that nothing is encoded, so it's a little bit easier to be like, give me all the transactions from this contract. But you probably want it even more fine-tuned than that, and so there are other indexers that allow you to like create custom tables that maybe it just filters out stuff you don't need, or if you have a really common query, it can optimize it by providing some indexes on it. Others allow you to actually process the data and transform strings to numbers, or combine data in different ways, do some math on the numbers. So maybe it doesn't show up as stroops, it shows up as a float point number. I don't know. There's all kinds of things you may want to do with your data. But yeah, there's like no two indexers are necessarily created equal. And depending on which indexer you choose, it's actually probably going to inform a bit how you build your contract. Because fundamentally, or at least for me, when I think about building a contract, nobody's going to be interacting with my contract over the CLI. Like there will be some application interface, either an actual website DApp that people are interacting with the contract, or there'll be cross-contract calls, and it'll be important that when those cross-contract calls are being crafted, they have appropriate information to know what kind of data do I need to pull in to places my arguments. Who owns what assets? How much of these assets do they have to available in their balance? There's all kinds of information that you may need to know, even as you're crafting another argument for a completely separate contract. So it does matter like the format that your storage takes and that your data takes. And then most of the indexers that we have pull information from events that you emit. So if you're familiar with, well, really any contract development platform, they have events that you can emit, and then indexers will grab a hold of those events, and those events are how you form the databases that you're building, whether it's a GraphQL endpoint or a Postgres database that maybe is exposed to a GraphQL endpoint, or your own database. It could be anything as far as that. However, it is kind of boiled down to the events. I understand that. I don't love it, and we'll get to a lot of times I am using event data, but then one of the nice things about Mercury, which has a tool called Zephyr, is you can actually pull in information completely outside of events. Like there's tons of information that comes through a transaction that's submitted on chain that has nothing to do with event data. And Stellar's got quite a lot of that. All the different things that changed, all the storage items that were touched, if you're updating storage information, what it was and what it is, when it's stored on Ledger, all the different contracts that were touched. Like there's so many pieces of information that are emitted when a transaction is submitted that have nothing to do with events. I do think events are helpful, but they're also a little bit limited, and they're not. I wouldn't say they're expensive, but they're not free to emit an event. Where transaction data is free. Well, in the sense of you're not submitting something like with an event, your contract works without events, right? It's not mission critical that you have an event for your contract to function. It's really just for like, I need to include some information so people know what's going on inside my contract for things like data indexing. But the contract technically will work completely fine without you needing to submit events. And so it's kind of like this, yeah, I guess I'm gonna have to pay for this, but it's kind of unfortunate that I do because it's not critical to the actual operation of the contract, which is always kind of a clue for me of, so maybe it shouldn't be on chain. Like if it's not necessary for the functionality of the contract, it's probably not the right place to put that data. So I try to limit where I'm able or where it doesn't matter the amount of events that I emit, and grabbing data that's already existing on the chain, things that are like side effects of the actual transaction being submitted itself. So looking at like transaction metadata when a transaction is submitted can really help with that. And again, when you're using Mercury, and when you're using Zephyr, we'll get into it a little bit, you have the ability to dig down into all of that transaction meta. Gets a little gnarly, but essentially you can run indexers without having to have any events. So that's one piece of Mercury. There is another one though, and that kind of addresses the one that we're going to look at right now with the RetroShades. Which is essentially, I think they've actually got a landing page for RetroShades, which is this idea of gasless events. So like I mentioned, events cost to emit them on Stellar. RetroShades is this idea of a gasless event, where you indicate inside of your contract code where you want a RetroShade event to live, but that event is separate. It lives separate from all the Stellar execution. And so what you end up doing when you run a RetroShade is you've actually got a parallel network that you upload your like RetroShaded contract to. So there's a Mercury, that's not even a side chain, it's just a parallel chain that runs in parallel with the main network, but it runs a modified piece of code, a modified contract that executes these actual RetroShades. So it runs every time the function runs, it sees that function running on the main network, and then it runs that parallel function on its like side network, sees the RetroShade event and emits that RetroShade event, which then populates a database. So that all is so there's docs for this. They're pretty good. I'm not going to get too deep into this. Well, if you go to that product page, you can see RetroShades there. I do want to go into some code though for this. I've got I think I've got this. I don't know that it's updated. But I think, yeah, I've got this. So for what it's worth, there is a demo here. I would not, let me update this. I mean, you could fiddle around with it if you want, but like nothing's been updated for 4 months. But I do want to talk about this and have wanted to talk about this for a while for how it works. So I'm going to open up the code here, and it's quite simple. I do have, when I originally built this, I don't know if it's in a different branch, but there's the Zephyr way of doing things, which is basically you make a Rust program that interprets ledger closes. And this is the power of Zephyr, where essentially there's a little hook that is called every time a ledger closes, and then you've got access to everything inside of that ledger. You might have to do a little bit of drilling down to find it and parse it, but that's amazing that there's a tool that exists that you have access to, where on a ledger close, you've got access to a hook that lets you dig into every single thing that happened on chain in that ledger. One of those being you can grab a hold of events, but you can also grab a hold of transactions or metadata, whatever. That's yep. And so it's not. It runs on every single ledger. So there is like a concept of subscriptions, but that is for catch-ups. If you want to retroactively go back in time and rerun your program off of contract data or transaction executions that happened in the past, you can subscribe to that. There's two separate. There's like Mercury, the tool set, and then there's Zephyr. I don't fiddle much with the Mercury side. I only work with the Zephyr side and some of the RetroShades stuff. But this closes on every single ledger. And then, so obviously what you'll probably want to be doing is making sure you're filtering, right? So I'm only interested in these particular contract addresses or these particular event prefixes or what have you. Otherwise, you're going to be bogged down by filtering way too much stuff because a lot happens in every single Stellar ledger. Cool. So we're not actually, in this particular example, we're not going to touch this Zephyr function. We're running RetroShades, which there's nothing you have to deploy or fiddle with. There's no Rust programs you have to write for the RetroShades side. In our case, so I have that folder, but that was for some other tests that I was running. For like, if I didn't have RetroShades, how would I accomplish the same thing? But I do have RetroShades, so I'm going to open up this. And I just have a really, really basic Sorbonne contract. This is like the hello world example, where it just prints out hello and whatever your to string is. So in our case, we might put world or Bob or whatever. And then there's also an event that gets emitted. And this is your classic Sorbonne event. This is the one you'll have to pay for. You pay based off of how much data you're emitting, like the number of bytes that you're emitting. So the less you emit, the better. But then it's also kind of like, yeah, but the whole point of this event is that I emit data that is useful to indexers. So you kind of want to emit as much as is useful. And it also you need to be able to like figure out what the context is. So a lot of times you'll have to prefix it with something like this is a transfer or this is a message or, something. So you end up actually emitting quite a bit of data. Again, it's not terribly expensive, but it's also one of those things where why are we paying for or emitting things that are not mission critical to the contract functionality and really just intended for like analytics or data digestion, which is really important, but don't pay for things that aren't mission critical is my philosophy, which is one of the reasons that I'm excited about things like RetroShades. So we've got this contract. And if we deployed this to the network, nothing interesting would happen other than it would emit events. And maybe you could use something like Zephyr to go in there, like I do in this example here, and it loops over all of the Sorbonne events. It looks and sees, hey, is the event contract the one that we expected? If it is, then go ahead and log whatever the event data was and save it into this database that I've created, which has just one column of name, and it will assume that hello, name, world, Bob, Joe, Tina would go in that database. A simpler way to do this is going to be with the RetroShade tool. So we'll have a second contract. You don't have to have a second contract. So if you look at this one, you'll notice that it's essentially identical, with the only added piece of functionality being this RetroShade feature being added, this mod being added, and then there's we're emitting the Sorbonne event, which we could omit if we wanted to, but because Mercury, in my case, Zephyr Mercury, like it's a third-party service. I don't want to have to rely solely on their RetroShade event. Like maybe other indexers someday will pick up Mercury's RetroShades, maybe they won't. So I'm gonna be emitting both events again, I'm only going to pay for this one, but it's kind of like the vanilla event. So I'm going to go ahead and keep submitting Sorbonne events, but I'm also going to add in a new RetroShade event. And so I set up my RetroShade. This is like configuring your database, as it were, where you've got the database and then the columns that are going to be in my database. So I'll have names and dates. It is a little bit unhelpful, I think, to think of RetroShades or even like Mercury databases, if you were to build them in Zephyr, as well as like static databases that you're putting data into and updating over time. I hope that over time the guys at Mercury will work on their database storage and make it a little bit easier to build out databases. But it's much more intended to be like sequential. So more like I have a particular event and I want to store that event as a unique event, rather than like updating a user and their I don't know, favorite food. You're not going to be updating that one row in the database. You'll be emitting, well, at this point in time, their favorite food was pizza. At this point in time, their favorite food was cookies. And so you might have a timestamp that says, like, give me the most recent value for this, but you're not necessarily updating that. And that's particularly true with RetroShades, where you have no ability to go like into the database and update something. It's always going to be brand new insertions that have like a transaction hash associated with them. So if you think about like, really useful for things like analytics, not so useful for things like what's my current balance right now. So if you have like analytics, you could track the balance over time and then pull the last one and know what the current balance is. But you could build a graph of this is all of the data from this user over time. I'm going to omit this one just for now, just for the sake of example. We'll just have names all typed, which is super nice, right? If you put in date, it's going to yell at you that you are missing. I don't know. It's just super nice. Versus just like random untyped enums or structs. So when we've got our RetroShade, we're going to need to deploy two things in this particular case. Let me pull up my Zephyr demo. And then, so like I said, you could put both of these. The reason that I don't include, in many cases, there will be some contract that already exists. This is one of the really cool things about this, right? You could take any contract. You could take the Kale contract, clone it, add RetroShade events to it, and then deploy that retro-shaded Kale contract to the Zephyr sidechain or whatever it is, parallel chain, and get RetroShade events into your own database that are all about the Kale contract, which is really quite cool. And that's one of the reasons that I run these two things separately, is like it's not the contract author, like the original contract author, that has to add the RetroShade events or add the events. You can go in, clone it, and then add your own events to it. And this is going to be really important because that doesn't exist right now in Sorbonne, right? Or the Stellar Smart Contracts. You wouldn't be able to go in and like, ooh, we kind of messed up that event, or it would have been really helpful if this event had this additional piece of information, or if we omitted additional events. You couldn't go in there and like redeploy the contract for that user. They'd either have to update it or you're just hosed. With the RetroShade thing, because it's on a parallel network, you can clone anybody's contract and just start emitting your own RetroShade events for their contract because it's running on this parallel chain. You can update it, you can modify it, you can run 10 different versions of it. They're all going to execute whenever that base, like in this case, the Kale contract, is called. It will call that same function, find your RetroShade, and emit it. So that's one of the reasons I separate these two things, just to kind of demonstrate, yes, we've got the Hello World contract that will be existing on the Stellar network, but then we'll have this retro hello, which is like a clone of the Hello World with the same function name, but we're going to emit our own RetroShade event for it, which is quite cool. We can add whatever we want to it, and it's far more typed and complex. Like your data, your ability to emit complex data to do math on it is far greater. You can do way more stuff with RetroShade events, and it's all free because you're not having to pay any sort of blockchain fee because it's executing on this parallel chain. So anyway, if we go to the run script, you'll see that we're deploying the Hello World contract. Actually, I think we're deploying the RetroShade one, which is kind of funny. I guess it doesn't matter because it strips out any of the optional features. So in this particular case, the RetroShade, we're going to deploy the same contract to both networks, but anywhere this feature is placed, because this feature is optional, it will be omitted when it's being deployed to Stellar, where it will be included when it's deployed to Mercury, because we include this feature flag of Mercury, which is what we have here, the Mercury feature. So we'll notice we build this, we don't include the feature flag, so it's going to omit all of the Mercury stuff. Then we deploy that contract to the Stellar testnet network, and then we go ahead and build the contract again, but this time with the Mercury feature. We get that WASM path for that. And then instead of deploying to Stellar, we use the Mercury CLI to deploy it to RetroShade. We give it a project name. We point it to a particular contract ID on mainnet. So it's like, what is my partner contract on the main network? So when it runs, I run. And then you give it the WASM target. And then I go ahead and emit a single event, which is hopefully going to trigger on the Mercury side to give me that RetroShade and start building out my brand new database. So let's go ahead and run that. And assuming this all works and deploys, we'll get a contract ID. There's our contract ID, which so that means it's deployed to the test network. And now we also deployed to the Mercury network, and we emitted the event. So if everything went well, we should be able to find a Mercury database somewhere in our account that has this address, or has this database with a row of name with a string of world. So Zephyr actually, or Mercury, I'm always going to get those confused, aren't I? Has a Zephyr demo. So I've got a bunch of projects in my account, and I've got this database, hello event, which is the name of my project, and then it's just got some random string that's my database. And if I execute that query, looks like I kept the same database string from my tests previously, and we've got world in here. We've also got Bob and world, which are some other ones that I emitted. So if I take this same transaction hash here, and I think I've got a command set up, but I've got a new contract address, so I should delete this one and paste the new one in, and then instead of Bob, we could say Elliot. That's you. And so that'll submit. And then again, that is actually running, right? I'm actually using the Stellar CLI. This is actually executing on Stellar, but because there's a Mercury, this Zephyr machine running on the side, it's got a parallel network that's looking for this contract address. And whenever that contract address is triggered, it's going to look for look up the function that we just called, and then look for any RetroShades, and emit those events, and then populate our database. So if everything went well, when we execute the query here, we should get a new row of Elliot. And there it is. And this is not something that you have to use. Like, this is an actual API call. So if I go over to my Postman and I put in the same, make sure that this database string is the same, and I run this, I should get all of my event names. So it's just a post to RetroShade v1. That's a little confusing. But anyway, you take this API call, it's a post, takes the authorization header, and then you just give it a query. In this case, it is just select all from the table. I could do select name where, select that from that where name, I don't know exactly what equals is supposed to be, but let's try this. There we go. It's just basic SQL, and you can do all of the filtering on there. And we could do the not Elliot. And now we get everything other than Elliot. Why is it less than greater than instead of just anything like, you know, JavaScript would expect? I don't know, but that's what it is. Yep. Limit to 2. It's just your normal SQL. So that's pretty cool. And all of a sudden, you get this like database for free. You didn't have to set up anything. You literally didn't even have to leave the contract editor, right? You're just writing your normal contract and including these RetroShades, and now you get a database. Again, the issue is, I mean, and you saw it here, kind of, right? There's no ability to be like, okay, but this row or this table or whatever, this field is my primary index or a unique index, right? We got world twice. And so you'd need to include something like a date so you could filter and find which one is my is the most recent if you're like wanting to have like stateful columns versus just time based columns. I think this one, I'm kind of fascinated by this. It seems like this string here is based off of what rows you include in your database. So my guess is this value will actually have changed this time because I have a different table with different rows. So if I call this, I'll probably get the same data, but if I look up here, I might have a different one now. Yeah, 3.9, because I have a new row in my, or a new column date in my field. So this one's actually new now, which is why I got my old one. It doesn't overwrite it. It bases it off of what your date and name or what columns you have in your database. Why it puts it as a float point, that's another question for the Mercury folks. But regardless, now we've got a date, so we could do things like where date is greater than or less than or between dates, which would be nice if you were trying to create something a little more stateful. Okay, so that is Mercury. That is RetroShades. They're awesome. They're going to have a ton of use cases for a lot of developers, but they are kind of limited in that you can't create stateful databases in the sense of like just having rows that you want to keep track of and you update those rows over time. And yeah, like it requires that you rely on Mercury for your database. And I don't love that, to be honest. Either A, I'd like to run this whole thing myself locally, which I actually think the Mercury guys are working on, where you can like self-host this. My guess is that's going to be pretty tough to do, where really the only thing I want to host myself is the data. So I want my own database. Currently, there's not really a great way to do that. There are a couple other indexers that exist for Stellar where you can plug in like your AWS Postgres database. So that's really nice, where there is some functionality there. But the other thing I want to show folks is how I'm doing most of my indexing, which is not using RetroShades. So we're going to toss this for a moment. And I'm going to pull in a new secret project that I've been working on. Yep. Mm-hmm. Yep. Great question. You specify two things. Shoot, I've already closed it. One of them is the contract ID that you're mirroring, and then there's the WASM hash. The WASM hash obviously is going to be different than the one on Stellar because it includes RetroShade events. But the thing that matters is that the function names are the same, the arguments, like the interface is the same. And then the contract ID, which is like when this contract ID is triggered, we're going to look up, do we have a parallel function for this to look for RetroShades off of the interface? Good question. Yeah, definitely one worth exploring, particularly if your needs are well suited to like sequential event rather than stateful. However, a lot of the work that I do is more stateful work where I'm trying to build an interface off of my data. And I need to know like what are the balances that everybody holds. So I'm working on another contract right now. I'm sure people have heard me talk about Glyph in the past. And this is actually going to be a simplified version of Glyph. I'm probably going to actually not call it Glyph because of that reason. I've got a domain name called smol.xyz, which I love so much. But it'll be very, very similar concept where you've got a pixel grid, like a 16 by 16 or however large, and you've got this grid, and you can select colors and mint this patterned glyph. So I like way back, like 2016, maybe it was 14, I don't know, ages ago. I built a color. It was like one of my very first projects was color glyph, and so loads and loads of glyphs. But this is the idea, and then these all get minted on chain. So I've always wanted to recreate this on mainnet with a lot more like mechanics behind it. So things like royalty payments, where the colors mean something a little bit more than they did in that particular model. I wanted to run it on a smart contract, but also keep it really efficient, and it's quite tricky. So for years I've been working on, way back when, it was one of the reasons I wanted to build Stellar turrets when we had this initial version of smart contracts, if anybody remembers turrets. Was I wanted like there was so much stuff that Stellar just couldn't do if I wanted to build something complex like Glyph on Stellar. So that gave rise to turrets, which then moved to what we have now as Sorbonne. And so what I want to do is now possible, but it would be pretty expensive. And so I'm working on that, and it's very hard. And I think I'm still probably waiting for a few more protocol releases to get to exactly where I need it. But in the meantime, I'm working on another version of this that has a little bit less complexity. One of the big pieces of complexity is I want people to be able to buy colors, and then when a glyph is sold with those colors, they get royalty payments when that glyph is sold. So like if you have a bunch of red and you give it to an artist, and then they make a really cool glyph with it, and then that glyph sells, you get some kickback based off of the percentage of that glyph that was sold with those colors that you originally purchased. So and that requires a lot of like cross-contract calls and a lot of tracking of here's this glyph, and you may not seem like a 16 by 16 or an 8 by 8 or 16 by 16 pixel grid has that much, but looping over 256 items pretty frequently gets pretty expensive. And so you're trying to come up with the right data model that minimizes those costs while still giving that functionality. So right now I'm working on another model that's got some of those components, but not all of them. But regardless, it's kind of like the next thing. I did Kale, and now I'm working on Glyph. This idea of like, let's make a bunch of fun things to do on chain. This is the next one on my list. I've got others, but I am really excited about this one. And some of the reason that I'm excited about it is because it does this one more than Kale did. Touches on the contract and a lot of like how to do complex things in a contract as cheaply as possible, and then how to index things but store them in your own database, and then from that index data build out a front end. So there's like a back end that sits between the indexer and the front end, so that all of the data is cached and quick and instantly up to date. And that's where Zephyr comes in. Is it kind of sits between the contract and those executions, and then every time a ledger closes, it sends off those events to one of my backends that then parses all those events and turns them into database entries. So let's go ahead and take a look at that real quick. So I've got my contract code, and I'm not going to leak. Actually, I think all of this is probably actually already on GitHub because I'm an obsessive open sourcer. But the the Zephyr contract program is very, very simple. All it's really doing is saying like, hey, okay, we've got a contract ID. That's what we're going to filter by. That's what we're going to look at, right? Every time a ledger closes, we're going to look up all of the Sorbonne events. We're going to see if that event is this small contract. And if it is, we're going to grab a hold of it. We're going to convert all of the topics and all of the data into XDR, like a string. And then we're going to send that data off to my backend. So rather than saving this in a Mercury database somewhere, I'm going to send a webhook off to my own backend. And so I've got an endpoint. It's identical to a webhook, where essentially Zephyr on close is going to emit a webhook off to my backend. And then my backend is what's going to process that request and store it wherever the heck I want to store it. So the Zephyr side of things, the indexer side of things is incredibly basic. It's just a webhook for events that come from my contract. So this does require a lot of back and forth as I think through inside of the contract, okay, what all do I need to send in this event? Because if I'm going to parse it by my backend, I really got to think through, do I have enough data to make the decision of what row to update? In my case, the big challenge, there's a couple of things you can do in this upcoming protocol. You can buy colors, but you buy like a whole color. So you can be the owner of particular colors, and then nobody else can buy them. And then anytime a glyph is sold with one of your colors that you own, you earn royalty payments. So if you own black or white, or, that beautiful 000FF blue, anytime a glyph is created with that color and then sells for with those colors, you get a percentage, right? If the whole thing, all 256, you'll get whatever the whole percentage. I think it's like right now static at like 8% or something, 8% of whatever that glyph sold for. So rather than like you buy individual colors, you buy the whole color, and that makes the math a lot easier and makes it much cheaper to keep track of things. But anyway, that's one thing you can do. You can also obviously mint glyphs, you can transfer glyphs. But the big piece that is tricky with all of these events is I have automatic order matching, where you can offer your glyphs for sale for a particular asset, or you can offer to buy glyphs with other assets. So like if Elliot made a really cool glyph, he can either choose to offer it for sale at a particular price of some other counter asset or counter glyph, or I can see it and say, I would buy this for this glyph or for this asset. And so you kind of sell and buy on both sides. And then my protocol does automatic order matching, where if there's a equal parallel counter offer, like Elliot's put it up for sale, I don't have to say, hey, I see that and I explicitly am taking that offer. You can just put up any sale that matches it, and it will just automatically match it so long as the asset and the amount match whatever Elliot had put up. And so that requires a bit of finagling on the event side, where I need to know, like, did it match? If it did, what glyph sold and who is it going to? Things that maybe the contract takes care of, but my backend will need to know about, so that in the interface that people are playing on, will know that the owner of this glyph has changed. The protocol knows that, but the interface doesn't necessarily. So you have to set up a bunch of these events that have like who bought it, or what sold, what bought, who's the owner, who's the new owner, who's the previous owner, who's the new owner. And then you've got a lot of different offer types, right? So you can sell a glyph for a glyph. You could sell a glyph for an asset. Either of those could be matched, or it wasn't matched, and so it's posted, but it's posted as a glyph for sale for an asset, or a glyph for sale for a glyph. And then you've got the inverse of that, which is I'm not selling a glyph, I'm actually selling an asset for a glyph. And I'm either selling an asset or I'm selling a glyph. And so there's like a couple of, it just gets a little bit complicated to do that order matching, but the bottom line is there's a limited number of events that are relatively complex, but all of that is just going to get forwarded ultimately to my backend. And let me pull that up. So you saw from the Zephyr side, Let's pull it up over here. I'm going to open up the Zephyr side. All it's doing is just forwarding a post where the body is the event body. So just the topics and the data. So all is base 64. So very, very simple. The part that then you have to take care of is on the back end side where you're actually parsing this. So I have a Cloudflare worker running that has an endpoint that's this, I think it's probably down at the bottom, just this Zephyr endpoint. So when that's hit, it'll trigger this massive function right now. I have not split any of this up because I rather go fast than clean at first. It takes all of the topics and it takes the data. It converts them into native JavaScript objects. So rather than being XDR, it parses them out. And then I start to parse out, okay, what was the topic? What was the function that was called? Depending on what the function was, that's going to change the event that was emitted to tell how these things should change. So if it was color claim, we're going to insert a new color owner. So we've got a table for that. We've got a table for glyphs that are being minted, where it's a brand new glyph. Congratulations. We have who owns it. We've got a function for transferring ownership, so you just transfer from one to the other. But all that data is coming right from the event that was emitted, and then like that webhook that was sent over to my backend. And then we get into all the offers. And this is like where I am currently working. So you can see all of my mess of comments to try and figure out all the different offers that are possible on this side. So we'll get there eventually. Right now I'm just trying to build out the backend. So essentially, again, all of those Zephyr events get emitted to my backend. I'm putting those items all inside of, they all get sent to this backend. I'm putting those all inside of a Postgres database, which then allows a very, very quick query of all of these items. Right, so here's like all of the glyphs that have been emitted, and so you have a really fast database that has exactly all of the information that I need. I'll include additional, like I need to add like what colors, like what does this glyph actually look like? So that doesn't come in the event. I'll need to expand that when I'm storing the glyph, I need to do a lookup on the ledger, because the ledger stores what colors are actually a part of this glyph, like what the makeup of it is. I don't put that in an event because that would make the event way too expensive, but I need it inside of my Postgres database. So I'll augment the event by looking up inside of this glyph mint. Instead of it just inserting the event, I'll have another lookup that says look up on chain this ledger key to see what colors actually exist, so that when I insert it as a glyph, I have all the colors, so that when I go and do a Postgres get, it pulls all the relevant information for that particular glyph. So I hope that's a little bit helpful for explaining how I'm currently thinking about indexing, particularly when it comes to Zephyr and events. And RetroShades are really powerful, but I am super keen on this particular method of grabbing a hold of data and like event data and then just spitting it onto my backend. What's cool about this too is I wouldn't need to use Sorbonne events. There's another, I'll give you a real tour into what's going on. So you saw how simple that one was. In my color glyph, I am trying to make color glyph as cheap as it absolutely possibly can be. So there are no events. This is the indexer. There are no events that get emitted inside of the color glyph contract, or there are very, very few of them. But there's a ton of information that's really important that whenever a transaction is executed. So instead of grabbing it in an event, I grab it inside of the transaction. So you saw how simple it was to get event data. This is how complex it is to try and parse that kind of like same type of information just from a transaction. It's a whole lot more difficult to get in there and grab a hold of it. And some of that's because the actual color glyph contract is so much more complicated on its offer matching and royalty payments and whatnot. But a lot of it's just parsing information out of transactions rather than trying to parse it out of explicit events. Could be a place where I could maybe use RetroShade events. But regardless, I do the same thing at the end of the day. Like I still am not using the Mercury databases. I do a ton of work to find what in the world is going on, what in the world should the information be, and then I just send it to my backend. Which this is all relatively defunct in that I'm working on other projects right now, but it's all baby steps, and it certainly is inspiring for other projects. So, but that's one way. If you don't want to use events or you want to parse more data on the Zephyr side, you can certainly do that. And then send it to your own backend. Cool. Any questions? Let me scroll through. I think I answered that one. Zephyr cannot be run locally right now, but I know that they're working on a version of this that can be loaded locally. SQL injection, that's all handled by Cloudflare. I don't know about. I know on the RetroShades side, I'm not sure. I know he's got, like, you can't do delete, but it also is like only your data. So if you're running it, like, don't run this from a front end, run it from your back end if you're going to do SQL queries. I don't know. I know he's got some stuff on there to protect against nefarious activities. I do know just being able to not put limits, like maybe nobody deletes all your data, but if you've got 10 billion rows and somebody doesn't put a limit on there and just literally does this, you're going to lock up the back end. So you don't want to expose this to a front end. You'll want to run that in the back end, and it requires JWT authentication anyways, and you wouldn't want to leak your JWT tokens to the front end unless you're crazy like me. Not that I ever do that. Surprised there's an ORM map to the API. Yeah, I've talked to him about doing that. Apparently it's non-trivial because of Rust. I'm not sure. Have you run into any want to have data? Yeah, so it's kind of what I was talking about. I certainly have. I don't love the vendor lock that Mercury currently has on the databases, which is why I'm excited about other alternatives with webhooks. Hopefully, maybe long-term, they'll let you insert credentials for forwarding that data onto your own databases. Other indexers do that. Maybe Mercury will eventually follow suit. Okay, I think that's everything. Anything on your end, Elliot? Yeah, there is an analog. It was heavily inspired. I think he mentions it by Shadow in EVM world, because if you think events are expensive on Stellar, try them on Ethereum. So this exists as this Shadow events inside of EVM. Yeah, I do know that it's in some ways it's a little bit different. The concept is completely the same, but because we're in Rust, there's a little bit more customization that we have available to us. But the concept's identical. Mm-hmm. Yep. Yeah, I actually have no idea I don't know what a Ethereum transaction looks like without events. That would be an interesting experiment. Maybe somebody else knows. Like, we have tons of metadata every single time a transaction is executed. So events are almost like, yeah, I guess they have them in Ethereum and everybody's expecting them, so we might as well include them. But you don't technically need them because everything that changes, all the arguments that are passed in a function call, every effect that happens is included by default without you having to emit events. Certainly there are times where you may want to do some math or do a read from storage and pull it in that would not necessarily be included in the effects of a transaction. So you may want to augment it a little bit, but you can get by without doing much event stuff in Sorbonne, where I don't think that's true in EVM, but I actually have no idea what a transaction form takes. I just know that anywhere I've ever looked for indexing anything on Ethereum never mentions that you can get that information from just a transaction execution in Ethereum. And so my guess is that particular aspect is kind of unique to Stellar, which is probably one of the reasons our databases are also typically just absolutely enormous, because there's so much information that's stored every time a transaction, or produced every time a transaction is closed. I think so. Yep. Yeah, that's another good one. I don't know how real time it is. I think it's pretty real time, but it does require customization, and I'm pretty sure it's all written in Go, which I don't know Go. So I know Rust. So I like what I've got available to me. I also don't know what their customization options are for like storage costs, where you can like limit what exactly you're storing or where you can forward it to. But if you're a Go developer, and maybe at some point we'll have more tooling. I know that a lot of the indexers actually out there use the CDP, which is pretty cool, to index all the data, and then you build your own indexing widgets, I guess, or endpoints on top of their data lake that CDP generates. But yeah, when I started looking at that, because I don't know Go and didn't want to stand up all this stuff, I did not know how to use it. Cool. Well, I appreciate everybody hanging out. We'll see you all next week. Have a fantastic week. Keep on building. Catch you on the next one.